Okay, so with this question here, you can see I've started to draw a force diagram for this setup. I haven't finished it yet, but I've got the weight of object A, okay, in place, and the weight of object B in place. So of course, string, there's tension in the string, okay, holding up that weight. So I'm going to put T there, and because it's a smooth pulley, string is inextensible, so it's not going to stretch. The tension's going to be the same throughout there. Okay. The other thing as well then, this is a rough surface, there's friction, okay, posing the motion. Okay, in that case there. And when it's set in motion, obviously this is going to fall down, so we're accelerating this way. Okay, and then object A is also accelerating down the plane. Okay, object B is going down this way, so we call that B there. For our reference, this will be A here. Now, because this angle alpha here, we need to consider this force here, and we're going to need to resolve, of course, this weight, because when we look at setting up equations, we need to go in the direction of motion, which is parallel to the plane. Okay, so we're using Newton's second law along there, so we need to see what 7g is, the effect that has along the plane. Okay, so in order to do that, remember now, if that's angle alpha, well, I can continue that line, the reaction there, which is perpendicular to the plane. I can continue that as a broken line, and of course then we appreciate that must be alpha here. Okay, so 7g then resolved perpendicular to the plane, that would be 7g cos alpha, and then parallel to the plane, we'll be going this way. That would be, the component there would be 7g sine alpha. Okay, so quite a lot of things going on here, but now we'll take our time to actually resolve. Okay, and then we can work out what they're asking for here. So for instance, they want the magnitude of the frictional force. We need to work out what that is. Okay, but the whole system is going to be going this way, and B is going to go downwards. Now, in terms of angles, right, tan alpha is 3/4, as it says in the question. So if you set up your diagram, of course, tan is TOA, so that's opposite over adjacent. So the opposite's 3, adjacent's 4. Hypotenuse then has got to be 5, isn't it? Because it's a 3, 4, 5 triangle, you can use Pythagoras. So sine alpha is opposite over hypotenuse, so it's 3 over 5. Cos alpha is adjacent over hypotenuse, 4/5. Okay, so if we resolve then, okay, let's look at A to start with. At A, okay, and we'll go, so we use Newton's second law in the direction of motion. So think about the direction of motion, that would be parallel to the plane. So we've got the tension pulling this object down, plus the weight component. Taking the object down, of course then the friction then is opposing it. And that would equal to the mass, which is 7 of object A, because we focus on A, times then the acceleration. Now if that's obviously resolving parallel to the plane. If we resolve perpendicular to the plane, we'll have R will equal to 7g cos alpha. Okay, now of course what's good is we know cos alpha to be 4 over 5, so we say therefore R will equal 7g, so 7 times 9.8 times 4 over 5. So work that out on my calculator, and we get out 54.88 newtons. Okay, now We can then work out the frictional force, because that's what it's asking, the question. Frictional force, obviously it's in motion, so we can say friction is equal to mu r. And remember, if you read the question, you said that mu is 0.6. So that would be 0.6 times then r. And we can work that out. So my calculator, I get 32.928 newtons. Alright? So I can put this frictional value here into my equation 1. Okay. And I can work out what that is in equation 1. So we'll have a few things worked out there. We won't know what T is, but we could sub this into 1. So say sub into 1. So we have T plus 7G, 7 times 9.8, times sine alpha, which is 3 over 5. Take away then, so I've done that there. Take away the friction, 32.928. That will equal then to 7a. Just tidy this up a little bit. So I'm working out what that is there. Remember the 7g sine alpha, so 7 times 9.8 times the sine alpha, which is 3 over 5. And then take away the 32.928. So I get T plus 8.232 equals to 7a, right? So that equation is going to be sort of important. Now we call that equation 2, because I've called that one 1 there. Now what we can do then is resolve at b. B is a lot easier, isn't it? So if I resolve at b, you just resolve them vertically. So these go in this way, so 3g take away t, and that will equal to mass times acceleration, 3a, so call that equation 3. And all you've got to do then with 2 and 3 is add them. If you add them, 2 and 3, it will eliminate the t's. T minus t disappears, yeah, when you add them, it'll be 0. So you just got to add that, 8.323 to add the 3g, which is 3 times 9.8. And that will equal these two added together, which is 10a. 8.232 add 3 times 9.8, which is 37.632, which equals to 10a. So therefore then a will be 3.7632 meters per second squared. Okay, so we've got the acceleration of the system. Alright, we've worked out the friction here, and of course we've got the tension then to be found by simply subbing it in then to say 2. Okay, so if we sub into 2, we can get the tension and then we're done. So sub into 2, so T plus 8.232 equals 7 times A, which is 3.7632. So rearrange that and we get the answer. We get the answer to be 18.11 newtons.